Let's look at an example of how to solve a u substitution problem. We're asked to find this indefinite integral. This is multiplication of two functions, so we cannot directly find this antiderivative. However, we can try u substitution to see if that will help. The first step is to make the correct choice for u. Here's a review of the steps for u substitution. Make a choice for u, find du, substitute u and du into the integrand. Once you do that, all the x's and dx's should be gone. It should be something you know how to take the antiderivative of in terms of u. And then the final step, reverse substitution to write the final answer in terms of x. So what should u equal for this example? Well, a good choice for u would be this inside part, 8 plus x cubed. Now we find u prime by taking the derivative of this with respect to x, which gives us 3x squared. The reason we know this is a good choice for u is because u prime appears in our integrand. Now let's find du. Du equals u prime times dx. U prime is 3x squared, so du equals 3x squared times dx. Now solve this for dx. We can do that by dividing both sides by 3x squared, and we get dx equals du over 3x squared. Now make a substitution. Substitute dx, which equals du over 3x squared, and substitute in u equals 8 plus x cubed. Now notice that we can cancel 3x squared. Now we've gotten rid of all the x's and dx's in our integrand, so we're ready to find the antiderivative. This antiderivative is easy to find. We can use the power rule, which tells us to add 1 to the exponent and divide by the new exponent. So we get u to the 6 over 6 plus c. Now the final step is to back substitute in terms of x. U equals 8 plus x cubed, plug that in, giving us this, 8 plus x cubed to the 6th power divided by 6 plus c.